In question 2, f of x is equal to ax squared plus bx plus c. B and c are real. It has a local minimum at 3 minus 1. And find the value of b and c. So local minimum at 3 minus 1. Let's say it's this point here. We have a quadratic coming down and up. This is the minimum point. We have a slope of a tangent at this point, which will be equal to 0. So if we differentiate our function to get slope at any point, f prime x is equal to 2x plus b. And if this is equal to 0, when x is equal to 3 here, the local minimum point, we get f prime 3 will be 2 times 3 plus b is equal to 0. So 6 plus b is equal to 0. So b is equal to minus 6. So if b is equal to minus 6, we're going to get, the function becomes x squared minus 6x plus c at any point is equal to 0. So let's put 3 in and we get an answer of minus 1. So f of 3 is equal to 9 minus 6 3's 18 plus c, and that's equal to minus 1 from here. So we're going to get minus 9 plus c equals minus 1. So c is equal to minus 1 plus 9. C is equal to 8 for part A. In part B, we have a limits question. Find the value of the following limit. We're told it's a natural number, and the limit as n approaches infinity. So let's take each one of them individually. Just a couple of ways to look at this. We could divide each one of these by n maybe to get 1 over 1 plus 1 over n. Let's divide them all by n. So that would be equal to 1 over 1 plus 1 over infinity. And 1 over infinity tends to 0. So this is going to be 1 over 1, which is 1. Or you could just say infinity over infinity plus 1 is going to be like 10 over 11. It's always going to be 1 apart, so it'll tend towards 1. This one here, we have, when we divide n from the bottom into the top, we're going to get 1 plus 1000 over n, which is 1000 over infinity. And 1000 over infinity you can see will tend to 0. So we're going to get 1 plus 0 in here, which is also equal to 1. So we currently have 1 plus 1. And then, well, we've done this before in limits, 1 over 3 to the power of n. It will become 1 over 3 to the power of infinity. And 1 to the power of anything is just 1. So this becomes 1 over 3 to the power of infinity, which gets really big really quickly. So this tends to 0. So we get 1 plus 1 plus 0. So the limit of this function is 2. C is a function defined for x between minus 2 and plus 2, which we can see here. Its graph is shown in each of the two diagrams, so they're identical. So we have g of x, or g of x will be y is equal to, our knowledge of functions here. Draw the graph of g of x minus 2, so that's y take away 2. So we take away 2 from every y value. If I start here, take away 2, 4 goes to 2, from 1 we'll go to minus 1, then from 3 we'll go to 1, so that looks about right. So curve and straight line, g of x minus 2. Looking at this one, g of x plus 3, you're thinking they want you to go in the positive direction, but our knowledge of quadratics, if we have x plus 2 to be squared, where is that on the graph? The factor will be x plus 2. You write it like this, by x plus 2. So the solution will be x minus 2 for my root. So when we add in here with g of x, we take away. So this is telling us to take away 3 from every x value. So if x is at minus 1, it goes to minus 4. If x is at minus 2, it's going to go to minus 5. And what else have we got? We have x at 2, so it's going to go to minus 1. So curve to there, straight line down to there. Now it does say in as large a domain as possible, but they don't give us any knowledge about where this graph goes after this point or this point, so I think this is what they're looking for here, just between 4 values. Just checking here, my work.